And welcome. This video is about how to remote control the Hewlett-Packard 34401A multimeter and using Windows Forms and C#. And thanks for joining me on this lovely warm day it is today in sunny UK. And I think have a look at programming in C# on Windows to control the HP34401A digital multimeter over RS-232. So first of all, we'll have a quick look at what in the information that's around. So we'll just switch over here, and this is the user manual. I come down here, it's the user guide. This is the Keysight one, even though mine's a HP meter, it's still the same. And what we're looking for is on page 150, down here somewhere. Here we go, 150 somewhere. There are information on the cabling, and what I have done to make life a little bit easier is I only have 2 and 3 TX and RX crossed over in the traditional null modem. I switched over, and I have DTR and DSR swapped, and on the PC side I have RTS and CTS linked together, so the PC will always think that it's clear to send, and it doesn't handshake over here. I'm not sure if the instrument uses these. It just makes life a little bit easier just to not wire them up. So that's basically what I've done, and I have gone through the menus on setting the meter up. If I go back to the meter here, it's in remote mode at the moment, so if we come out of that, now to get to the menus, it's a matter of shift, menu, and then we want E, and down, commands, and then we got the 1, interface, down, RS-232, and then you use the auto manual to enter and come out. And it's the same with the baud rate. You can go in, baud rate, and I've got it on the top. You can just cycle around them. So that's how you get into the setups. A useful one to know this is a useful one. That's how you get to the errors. And to clear the errors, you hit the enter button. So that's a useful one to get rid of the error message on the screen if you do get it. Right, I won't go into this in too much detail as there is a lot. I recommend that you download the user manual and familiarize yourself with all the commands it has. And you want to look up the SCPI, which down here stands for Standard Commands for Programmable Instruments. And a lot of instruments will use this. It's pretty standard. Lots of manufacturers use the same syntax. And as you can see, this is the one we've already seen, the measure voltage DC ? Because you're asking for a reading, and then range 10 volts. Then there's all the other things that you can stick on it. And then again, you see that there's DC, AC current, DC resistance, frequency, period. All the things you can do on the front panel, you can do here. And as you can see, there are lots of them. You can set it into all the different modes. I think one of the only things you can't do is switch between the front connector and the rear connectors. Is about the only thing you can't do. If you can do it on the front panel, apart from that, you can do it with these. And so I'm not going to go through it in detail at all because it would just take too long. And yeah, your best bet, download the manual if you need to, go onto these pages, read all these, and then play with a meter, as I think that's the best way to work out how all these work. The hardest bit is getting the C# to interpret what comes in into a reasonable value that you can use and store. Right, join me here. I've just opened Visual Studio 2019 and we're going to create a new project for this. And my favorite, because it's easy to use, well, relatively easy to use and quick, is the Windows Forms. And I'll do it in C# because it's, it's simple. We're going to call it HP34401A remote demo. So we'll create that. So there's our form. So we can run that. And what do we get? A form. Close it down. So what do we need? Right, we've created our form. We've named it. What do we need now? We need some buttons. Let's just start with 2 buttons. One to set it to remote, and one to initiate a measurement. And then we need to be able to talk to it. So we need the serial port. So add a serial port. I can click on that to bring it into focus. We can go over here. We can see the serial port is still called serial port 1. It's already set to the 9600 we need. It's got 8 bits. Now my RS232 is on COM6, and I know we need 2 stop bits. So that's a very simple way of setting up the COM port. Not the best way of doing it. You're better off putting it into your program, but for short and sweet, this works. So then we want to go into the button 1, and just for the heck of it, we're going to call it remote, because that's the function it's going to do if you press it at this current moment in time. And we're going to set the background color, because I like to have colors to show doing things, to red. So there we have. And then we click on it, double click on this, and that will open up the program for it. And here we have button 1 click. So that's doing everything we need to know. So we just need to add some contents for it. Now we also want to know which state the button is in. We are going to put in a variable up here. A boolean's good for that, and we'll call it meter remote state. And currently it's false because it's in local mode, and then we can use it later on. So right, so basically then when this button is clicked, we want to know, are we going to remote command or local command? So we check that boolean that we just put in, and if it's false, so if it's not true, then we want to set it true. So we'll set it true now, because obviously that's what we're doing. And just to make it look pretty, I'm going to change the text on the button so that you know from looking at the button what mode it's in. And I like to change the color. So I can't talk and type at the same time. I like to change the color. It's an indication that I've clicked the button and something's happened. So that's what I want to do. That's how I like to do it. And then I want to know, is the serial port open? So we'll check for that. Because obviously if it's open, I don't want to open it again. So it obviously isn't open, so we can get down to here and we can open it. And because we want to go straight into the meter and telling it to go into remote mode, we need to write to the serial port. We need a new keyboard. This keyboard's a bit small. We need to write, as I said, and it's a system command, so it's SYS system. You can go into lowercase for the rest of the word, and then it's remote REM, and then we want control line feed, and that should put us into the remote mode. Next time round, when the button's pressed, obviously it's now in its true state. It is in remote, so we want to put the meter state back to false because we are going to put it into local mode. We're going to put the button text to remote again because that's its next function it will do when you press it. We'll put the background color to red, plus, just to be on the safe side, we'll check if the serial port again is open. There is no protection being put in this program whatsoever, so if you do encounter any errors, it will fall over and it can bite you. Oops. And we're going to send it a system command to go local with a carriage return line feed at the end of it. And then we're going to close. We're going to close the port. So we can click on the start button and that will let us know if it runs. I like doing this a lot because there you go. We now have a remote button, and if we're lucky, bring that up. You can see remote, local, remote, local. So that's working. Close that down. Button 2. Now down here we can put button 2 and we'll just call it measure. Oh, it's going to be DC, so measure DC. There you go, a button. Click on there. This is the event that will be called when that button is clicked. And what we want to do? Well, first of all, again, I want to know if it's open. I'm not going to do anything if it's not open because that will automatically throw a wobbly. There's other ways around it. I'm not saying I'm the master of C# and catching exceptions and things like that. But this is just a demonstration of how quickly it is. With this, you can do it. Right, short for partly for measure. Then we want volts or voltage. We want DC question mark because we're going to ask for a response on range 10 or 10 volt range and a new line, and that should be enough that if we run it again, bring the screen back in, bring that up, go to remote, and as you see, when it's in remote there's no reading because it's not been told to do anything. Now hopefully when we press on the measure DC, up pops the voltage. You keep clicking on it, so change that. See, nothing's happened, but you may notice it doesn't like it. So what doesn't it like? Again, as you remember, shift, oops, shift, menus, system, error, 410. Now, we may have to look that up. But first of all, let's look at the program and see if the program is wrong. It should be measure volts DC 10. No, I don't see a problem with that. Not quite sure. Let's come out of the error. Didn't like that. Bring that back. Right, I had a quick look. All the fun and games with the error messages were caused by, if I go down to serial port, I had DTR enable as false, and the meter wants to use DTR and DSR. So that was obviously false, and that was causing a problem. Set it to true, so now it's running it, and we start the program. Bring that over onto the screen so you can see it's that. Bring that up so you can see the meter. Meter currently says 1. It's currently in remote, so it's on. Put it back into manual mode, so it's measuring it. We'll go to remote mode. See it stop reading. So if I make that 6 volts, and we hit the measure, and we've measured 6 volts. Bit of a wobbly disc today. So we can now we know that we can put the meter in and out of remote mode, and we can make it do a measurement. So next is we need to have a way of displaying that measurement. So on here, we're going to want somewhere where we can put something out. So we'll have a text box. Click on there because we want a multi-line text box. Put it down there. You could always bring that in if you want to. So there's our text box, and it's called text box. Come back to here. Now, I have a lot of problems. It's going to be a bit awkward because I'm not 100% sure what I'm doing. You know, there's no point being in it. I'm never going to say that I'm an expert, but I get by. And I've always managed to get things working after a fashion. Now, normally you would just do text box dot amend text, and it would put the text in the text box. But when you're using the RS-232, you need to know if the system has received a message. And for some reason, well, we can do this. If we go back to here, click on that, over to here. This is so data received. So we now have a serial port 1 data receive. Now that will get called if ever the UART in the PC gets any data in it. So you could simply go text box 1 dot append text serial 1 dot read line. That would be a normal way of putting whatever that sends back into the text box. But if we run it, what will happen is, I won't show the meter because it doesn't matter. We'll go to remote, we'll hit the measure, and we throw a wobbly because we have a cross-thread operation not valid. Because there are threads running, and obviously the serial port data received is a different thread to the screen on the main form, and so it doesn't like it. And there is some serious bits of workaround that we need to do. And one of them is we need to go up here and we need to delegate some of the functions. And they're public, delegate. It doesn't pass anything back, so it's void, and we're going to call it add data delegate, and it's going to be passed a string, and it's going to be, the string's going to be called HP34401A data. So I recommend you look this up on this afterwards. Public add data delegate. I'm going to call it my delegate. Get rid of that. Did I spell it right? Yeah, you just move places right. So there. And then what we also need is we need the methody thing. So we're going to have a public void method, and it's going to retrieve a string, and we're going to call it data. Thunderbugs are annoying. Right, and so this time this delegate is going to be able to send things to the text box. So here we can append text, and what we're going to do is we're going to put some things in front of it. received data. We do that. Then we're going to add the data in, and then at the end of it we're going to throw in a new line character, which has gone wrong. Who said that I could program? Oh, I don't know. Right, so that should be happy there. And then we come down to the bit here. We've got to get rid of that bit. So what we're going to do, get rid of that. So we want a variable. We'll call it again data, and that's going to equal. Oh, I want that. Programming with warts and all. So we're going to read the line in, and now we want the text box, and we're going to invoke and delegate. It's a new object. Data. Right, what we need to do is we need to set the delegate up so it knows how to pass information to it. So we go to the Form 1 Designer, and where we got all the initializing components, we want to add one. Now it does say that you shouldn't play around with here, but I find it's not always a problem. So my delegate equals new add data delegate, add data method. Right, hopefully this should be enough. Oops, try and pick up that bit to bring it back to into remote. Hey! Success. Now, just made that bigger so you can see it. Hit the button. Into remote. Measure it. Change the voltage. Hit the button. Measure it. Simple-ish. Well, I hope that's whet your appetite as to what you can do in C# in Windows with forms. Not easy, but there are lots of explanations out there on the internet on how to use it, and it doesn't take much to, once you've worked out roughly how to do it, doesn't take much to get a program up and running. The only thing I can say is, with this type of style of this program here, if the meter was very, very slow, say you set it down to its slowest baud rate, when you clicked measure, until it had received all the data and printed it onto the screen, no buttons here would work, because when you press a button, the program goes away and does something, and it takes the focus away from the form. So the form is effectively dead until that process is finished and comes back, and then the form becomes back, the form gets the focus, and the buttons will all start working again. So to do this properly, you have to put the meter reading in a background thread, but that'll be a later video. And then when you hit, say, the measure button, you invoke the background thread, which does all the meter readings. Because it's a background process in a threaded process, the form carries on running because it's just chucked it away for someone else to do the work. It carries on running and waits for that to finish, and then it can display it. Another day, another video. But if you liked what you saw and you think my programming skills are crazy, click on that subscribe button, hit that bell, and I'll see you on the next video.